Good morning, class. This is the warm-ups for this week. I'm going to go through those with you. Here we go. This first one, Monday, says the graph represents the height. So that means that y represents the height in feet of the rocket of the function, okay, in time, seconds. X is going to be time, okay? X is always going to be time, seconds, minutes, years, days. X is time. Your y is always going to fluctuate. So here, your y is going to be the height. Okay, the height. All right. So it says use the graph to answer the following questions. Okay, these are your seconds here. This is 0 seconds, 1, 2, 3, 4, 5, 6. This is 7, and this is 8, okay? Along the side, this is 50. The height is 50, 100, 150, 200, 250, and 300. All right, let's make sure we can read the graph. The first question is, what is the practical domain? Okay, practical is what makes sense, okay? Domain are going to be your x values. So it's your x values that make sense as it pertains to the context of the problem. Well, in the problem, it's talking about a rocket and its height versus the seconds. So in 0 seconds, the height is right here, which is between 150 and 200. So maybe 175 in here, okay? And it reads thus the same across the graph. You notice that because it's at 0 height, this is the rocket started at this height right here, which we said was about 175. That's the starting amount, because in 0 seconds, that's where it was in height, okay? That's where it started off. Now, the other 0 over here is when the rocket hit the ground. And this is the point in which the rocket hit the ground right here, hit ground. And I know that it hit the ground here because the height is 0. So when the height is 0, it has to hit the ground. So from here to here is going to be my practical domain, because seconds can't be a negative number. So my practical domain is going to go from 0 to, and this is about halfway between 7 and 8, so that's from 0 to 7.5. So my practical domain is going to be from 0 all the way to 7.5. This is my practical domain here, okay? Beyond this, you can't have negative height either. So beyond this, the graph does not make sense. After it hits the ground, that's it, okay? Because it's at the ground. Why? Just explain why, all right? It says, what is the height of the rocket in 2 seconds? So we're going to go to 2 seconds on the graph, which is right here, and go up to the line. And right here is the line. So that's about 300. You see that? So the height after 2 seconds is about, let's see, y is about 300, okay, feet. All right, give or take a few. A little bit over, might be between 300, 310. So if you got somewhere in there, that's cool. Any questions about that? Okay, so now we're doing Tuesday. I'm asking any questions about that. If you have any questions, just text me, okay? All right, here we go. The graph represents the height in seconds. This is Tuesday's warm-up. Oops. Wait a minute. Oh. This is Tuesday's. Sorry, y'all. All right. It says find the average rate of change, okay? The average rate of change. We know to find the rate of change, you use the formula y2 minus y1 over x2 minus x1. That's how you find the rate of change. Well, we're finding the rate of change for this function over this time, where your x is 1 and then your x is 5. So we need to find those ordered pairs so that we can use the formula for rate of change to figure out what the rate of change is. We know that this x value is 1. We don't know what the y is. And we know that the other x value is 5. And we don't know what the y is. So that's what we need to find. We need to find the y for both of those ordered pairs using this function here. So let's substitute the first one. So over here we have, let's do x squared plus 2x minus 5. And we're going to substitute 1 to figure out what y is, all right? So when we do that, let's see. All right, so when we do that, we have 1 here, 1 squared. Do I need some more lead? Okay, let's see here. We have 1 squared plus we have 2 times 1 minus 5. Okay, that's what we have. So here, this is going to give me 1. Then we have plus 2. Then we have minus 5. Okay? All right, so here we are going to put, this is 3. Then we got minus 5. This gives me a negative 2. Okay? So again, we plug this 1 in here. When we plug the 1 in, this is what we get for y. So we're going to put here negative 2. All right. We're going to do the same thing for 5. We have x squared plus 2x minus 5. We're going to plug in 5. So we got 5 squared plus 2 times 5 minus 5. So 5 squared gives us 25. Then we got plus 10 minus your 5. Okay. All right. So here, when we add these two together, this is going to be 35 minus 5 gives us 30. So here we're going to get 30. Okay. So now we use the slope formula, figured out what the average rate of change is from this point right here, where x is 1, and this point right here, where x is 5. So this is my first point, and this is my second point. So I'm going to use the formula y2 minus y1 over x2 minus x1. We've done that many times before. So when we substitute, our y2 is 30 minus our y1 is negative 2. Our x2 is 5 minus our x1, which is 1. So this gives us on the top plus a positive. So that's going to be 32, 4 divided by 4, which is going to give me 8. So the average rate of change here is going to be 8. Okay? All right, that's Tuesday. Wednesday, this is without the calculator, using graphing capabilities, you have f of x, which is the same as y, is equal to x squared plus 7x plus 10. Identify your x-intercepts. That means where this parabola, the U shape, because we have a squared term here, where our parabola crosses the x-axis, then where our parabola crosses the y-axis, and then what that minimum and maximum point is, which your minimum and maximum point is going to be your vertex. Okay, if it's a upward parabola, then your vertex, upward parabola, this vertex right here is going to be minimum, okay? Because it's the lowest point on the parabola. If it's a downward parabola, okay, then your vertex is going to be maximum because it's the highest point of the parabola. So your vertex can be either or. It can't be both, all right? When a term, the number that's attached to the x is a positive, then you get a parabola that looks like this. So A is equal to a positive number, okay? This is what you get here, okay? It's gonna be maximum. When A is a, why did I say that? Sorry. I don't know what I'm thinking. This is when A is positive, upward parabola. When A is negative number, downward parabola. Sorry, y'all, I'm tripping. All right, so let's find the x-intercepts. To find the x-intercepts without the calculator, what you have to do is factor and then set each of those factors equal to 0. So we're going to do x-intercept first. Okay, so to find x-intercept, you're going to factor and solve. So when you factor this trinomial, because this first term right here is a 1, okay, automatically a 1, you're going to use your factor sum chart. So you factor the last number, and the two numbers that you factor have to add up to the middle number. Okay? So 2 that comes off the top of our minds is probably 2 and 5. And that's correct. 2 plus 5 is equal to 7. So what you have, you got x times x, which is going to give me x squared. And then you're going to use 2 and 5. So that's plus 2 and plus 5. So after you factor, you're going to set each of those factors equal to 0. So here we got x plus 2 is equal to 0, and x plus 5 is equal to 0. So when I subtract, this gives me x is equal to a negative 2. When I subtract, this gives me x is equal to a negative 5. So these are my x-intercepts. This is negative 2, comma 0, and this is negative 5, comma 0. Those are my x-intercepts, or my roots, or my zeros, okay? Now we find the vertex. To find the vertex, the first thing we have to do is label. You want to find the vertex. So you can, you already know that since this is a positive, your vertex is going to be minimal, okay? So you need to label your A, your B, and your C of this quadratic function, okay? Your A is the coefficient in front of this x term, which is 1, x squared term. Your B is the coefficient in front of this x term, which is 7. And your C is going to be 10, which is also your y-intercept. So we're going to label our y-intercept is going to be 10. C, or your constant, the number that has no variable attached to it, is always going to be your y-intercept, which is 10 there. So now you find the x value of the vertex by using the axis of symmetry formula. X is equal to negative b divided by 2a. Okay. All right, so our b is going to be 7. So that gives me x is equal to, the negative is already there. We're just going to substitute the 7. 2 times a is 1. So this is going to be a negative 3.5. That is going to be the x coordinate of your vertex. To find the y coordinate of your vertex, you're going to substitute negative 3.5 into the equation. So this is y, or f of x, is equal to so now let's plug that in, okay? So when we plug it in to figure out what y is, we plug in the negative 3.5 and you square it, plus 7 times negative 3.5 plus 10. We use order of operations there. So when we multiply the two together, we're going to get 12.25. Okay? When we multiply the 7 here times this slide this over again, times this negative 3.5, we're going to get negative 24.5. And then we got plus 10. So when we combine those terms together, we get a negative 2.25. Or a negative 2 and 25 hundredths. So your vertex is going to be negative 3.5, comma, negative 2.25. And again, since A is positive, it's going to be the minimum value. It's going to be your minimum value. It's an upward parabola. Okay? All right. Hope this helps. Make sure you go back and correct your warm-ups and submit to Remind 101. All right.